We're excited for our next talk. It's with Sowmya, Ganapathi, Krishnan. She is the head of data and AI for Thoughtworks Southeast Asia. Originally from India, she has over 12 years experience in technology, the past 8 in data space. Her aspiration is really to use tech and data for good, for social good, especially for differently abled people. When we asked Sowmya what's her secret talent or something that we don't know about her, she said that she has this innate ability to show up on location, on time, not a second earlier, not a second later. Pretty interesting, given that we're trying to be on time today. I would love to test this theory. And if you would like to as well, you can take out your timers. Here's Sowmya.
Thank you all. I think I arrived on time here. Thanks for that. It's a tricky time to go for a presentation. It's right after lunch, and I was just worried that, it's a dark room, and I'm going to be talking about some data mesh stuff, and thanks to Edward and Sarah that, you kind of loosened up, right? Are you loosened up? Yeah? Some more noise, please, for the afternoon. Are you loosened up? Yeah. Fantastic. So it's great to see you all face-to-face and have this talk. So before I set out to talk about data mesh, just a show of hands, or how many of you are data engineers, data scientists, analysts, awesome folks in the data space? Please raise your hands. Quite a few, nice. How many are devs here? Awesome, really nice. Cool. How many of you heard about data mesh before? Oh, that's quite a good number. Okay. So looking for some very interesting questions after the session. So just getting started. So maybe from the audience, I just want to those who know about data mesh. What is data mesh according to you? Maybe just skip the one on the slide. Anyone wants to go? The folks on this side who raised your hand. Not the front row, folks. Anyone from the audience? OK, I'll take the first step. So how many of you think data mesh is a product? How many of you think, OK, there are a few folks who think it's a product. OK, how many of you think it's a tool, library that you could use to get things through? OK. So what it's not a product, it's not a tool. So data mesh is a paradigm that originated in Thoughtworks a couple of years back by Zhamak Dehghani, Director of Emerging Technologies. What it is an approach to data architecture, especially in the big data space, in order to scale analytical use cases, right? So we're going to talk about that in a much more detail today, and let's keep it interactive with as many questions coming in. So data mesh is a socio-technical approach in the sense it's not just a technical way of doing it, but it involves organizational changes that are needed to see domain as a first-class concern, to treat data as a product, and be able to bring in the folks who understand that data the best to own it, right? A lot of things I'm throwing around, and we'll dissect this as we go along in the session, right? So when do you consider data mesh? I know all the data scientists and engineers out there. Are you dealing with terabytes of data already? Anyone with terabytes of data? There are a few. Petabytes? Wow, super cool. OK, so when to consider data mesh? So you're talking about use cases where you need to aggregate data from a lot of sources. Say fraud detection, right? You're actually getting in data from lots of sources, and this is terabytes and terabytes of data that you need to write your fraud detection model on, right? And many of you might be from enterprises where you have large number of producers and consumers. Anyone here who is not using data at all in your day-to-day life? Like, I'm not getting data from anyone. Anyone like that? Who is not using data? But if you're using data, you will see that there are a large number of producers and consumers in any sort of an enterprise, right? And then you have complex domains such as, you might be writing machine learning models, you're writing rule-based engines, and you have a lot of teams that are sharing data with one another. In a typical setup, maybe in some of your enterprises, you will see that teams are always sharing data with each other, right? And consequently, there is an overlap of use cases. It's the same thing that every team is actually doing. Hey, I want to get that Excel file. You won't have one place that gives that. You will actually reconstruct the Excel file yourself, right? So these are all places where data mesh can add a lot of value, bringing in a lot of value to democratize data and share data with one another, right? So why is it important? Okay, I'm not able to get a gauge of the audience now. It's even darker. Why is it important? How many of you are in data platform teams that are, you're actually the team in the center and building the pipelines? From sitting in the data platform teams, data engineers. Okay, maybe I'm seeing some raise of hands, but I'm just gauging from the shadows. So, okay, why is it important? In a recent study, what we have seen is around just 24% of enterprises have actually been successful in becoming data-driven. This is just 24%. But if you see, there are a lot of enterprises that are setting up data lakes, data warehouses, on-prem, cloud, you name it, it's there. But why are we not becoming data-driven? Some of the issues that we see are data quality issues. Now, you have data, but can I trust the data? Maybe not, right? Why do we get data quality issues? Because there is no people and process ownership around this data. And there is a central data platform team that's overworked. We are not able to hire data engineers, and there's a cost to the firm, right? So all these have actually made it difficult for the enterprises to bootstrap and scale with their setup to become data-driven. Now, maybe let me narrate my experience as a data engineer, right? I've been a data engineer in many setups for the last 8+ years. And if you see, there is this, I'm not sure if you're able to see the laser, but the ETL pipeline that you see here is this data platform team, which constitutes of all hyper-specialized data engineers who are forever, these are ninjas who can write ETL pipelines. You can actually write data pipelines on Spark. You can actually get it from one place to another, give it off to consumers, right? But what's happening today is this team is also tasked with helping the consumers. Now, I know there are a lot of data scientists in this audience, right? When you go and ask a question about, hey, I want to use this for writing a machine learning model for, say, smart nudging, right? I want to give a smart nudge out saying that you need to walk 5,000 steps today. You need to drink 3 more liters of water. Do you get the data immediately, and from whom? Do you get it from the data engineers, or do you get it from the source? Some of the data scientists out there, where do you get it from? Any takers from the audience? I saw some hands going up. I should have registered who it was. So usually, the data engineering team or the data platform team is always tasked with, hey, I need this data. But this data platform team, unfortunately, is in the business of writing good data pipelines, but they don't understand the data. Now, who understands this data? Is from the people who actually generate this data, which is the folks in the operational data plane, right? The ones who are generating the data for transactional needs are best placed to actually give the data out for analytical needs as well. Now, given this data platform team in the middle is always stuck in this limbo of consumers are coming to them to ask for, give me this data, what does this data mean? And they also need to build the data platform. So they are forever overworked, and they're forever in this process of, failing to bootstrap the existing data lakes and warehouses, right? The second is, they are not the folks who understand this data. The producers are the ones who understand this data. So because of which, they don't have the time to build the data platform well. So there's a lot of tech debt that goes in today's data platforms, right? And you're also moving from on-prem to cloud. And that makes things even worse. So what is the challenge that we see today is that we don't have proper ownership of data. It's the data platform team of hyper-specialized data engineers who are also tasked with understanding the data, which they don't because it comes from a very different source, and it's giving it out for consumption. They are unable to derive value out of it. And this is the exact challenge that data mesh tries to solve, and we'll see how, right? So the objective of data mesh is to actually bring together the operational and the analytical planes, which means if you are the team that's in the business of giving data for operational needs, you are also the best person to give off the data for analytical needs, and that's the objective of data mesh. And as we go along, we'll get to dissect this. How does this happen, right? If you're a team, should you write things from scratch for analytical needs? How can I do that? And we'll try to answer all of these in the upcoming slides. So how does it work? There are 4 principles of data mesh, and all 4 of them need to come together to say that, hey, this works with the data mesh approach. The first one being domain-oriented decentralization. The second is data as a product. The third is self-serve data platform. The fourth is quite a mouthful of words, federated computational governance, right? And we'll try to actually dissect each of them as we go along, right? What is domain ownership? So how many of you have built a microservice so far in your setups? Awesome, quite a few. So you know domain-driven design well. Can I assume whoever has raised your hands? Okay. So domain ownership is nothing but extending domain-driven design to the data space as well. So if you see today, data is seen as a monolith, just like how systems were seen as monolith a decade back, right? So what domain ownership tries to do is, don't see your data as a monolith, as a swamp that no one owns, but look at data as decentralized across domains. And what does a domain mean in simplistic terms? It's this sphere or boundary of knowledge and activities which has a purpose, a business purpose attached to it. And there are teams and systems that are working in that domain towards that purpose. For instance, in every company you have a payroll domain. You have a human resources domain. You have a financial domain, which in many places finance will have many subdomains. But in simplistic case, it could be that if I'm running a health analytics company, I probably have domains which finance is taking care of, my day-to-day BAU. There is an activity domain that's collecting health data for analytics, right? So when we say domain ownership, what we are saying is, let's decentralize data across these domains, where the teams and systems who are actually generating data on a day-to-day basis for payroll, maybe, are best placed to give you the data for analytical needs as well. And that's the premise of domain ownership, right? And we'll see how this gets possible. So once you decentralize, what you're saying is, this team, which is in the business of giving data for transactional needs, is also giving data for analytical needs. With a strong ownership in place, like you have the data owners who are taking care of the, making sure that the approval to the data comes through fine. The quality of data is good and trustworthy. There's the data stewards who make sure that they are able to take care of the processes day to day to help the data owner, right? And data product owner, we'll talk about that a little bit more. Data product owner is always thinking about, hey, I have so much data, then how can I actually best derive the value out of it? And developers who are working to build the business logic to give out for analytical needs, right? All these roles should be in place to say that I have data in my domain, it's trustworthy, it can be used for these use cases, and we have accountability of who owns this data, right? That's the first pillar of data mesh, which is domain ownership. So to give you an example, right? Many of you might be using Spotify, a lot of those apps. And in a typical setup, you might see something like an artist as a domain, right? Podcast as a domain, media as a domain. Now, the ones that you see as labeled as O are all operational APIs, which are, in a day-to-day basis, you're actually building a microservice that can give out APIs to onboard a new artist, pay an artist, right? What we are also saying is this one thing that's labeled as D is I'm also giving data for analytical needs, which could be that I'm giving you history of artist data for building machine learning models. Or I'm giving you the podcast listeners' demographic so that you can make some decision making on, hey, this particular area is having a lot of podcast listeners, so what are they listening to? Let's try to recommend on the same lines, right? So if you see this, within these domains, they are taking care of both the operational and the analytical needs with that domain. And these domains, are they in silo? No, because they actually have APIs where, for instance, Media has an API to give out daily stream of artists, which is consumed by artist domain. And artist domain can use that for several use cases. So each of these domains interact with each other to form more aggregated domains, right? So the first aspect of data mesh is you look at data not as a monolith, but decentralize it across domains with boundaries which are tied to business purposes. And you have the right accountability for data within these domains. That's the first pillar of data mesh, right? Now, data as a product. Right? What is a product? I think I'm not a product owner, and Edward and Sarah might probably bite me if I say something wrong. But what is a product? A product is nothing but, to me, as a layman, as a user who is using this, it actually solves a purpose for my needs, right? It entices me with some value, simply put, right? Now today, if you see data as a product, many companies, when we speak to, they say, hey, we are awesome at collecting data. We have done a lot of infrastructure setup. We have this much data, but hey, we don't have any use cases for this. What's the value of this data then? Zero, right? You have this data, it's not being used by anyone, so it's not a product at all. So the second aspect of data mesh is to see data as a product. And when can you actually say data is a product? Is when you're looking at that there are 6 characteristics that we are seeing here. One is discoverability, right? So let's take the same example of I'm a data scientist who wants to do health analytics, and I want to generate smart nudges. So for me to know which data sets are actually important to do this is first I should be able to discover this data. And how can you discover this data? When you have a data catalog where all the data sets in the firm are registered, you can come there and say that, hey, I have these data sets in this data catalog. I can actually use them for my generating smart nudges. The first principle is that it's discoverable via a data catalog where the data sets are registered to, right? Now I have discovered this data. How do you address this data, or how do you access this data? That's the second part. So I know that these data sets are important for me to generate smart nudges. Now I should know how to access them, right? It could be via an SFTP server, it could be via REST API, it could be via a database, but I should know exactly how do I actually address this. It's the second aspect of calling that this data set is a product, right? The third one is trustworthiness. It's a very, very important aspect of data as a product. Now, if I'm drinking a bottle of water, right, you actually look at the water bottle's label to say that, hey, what processing has gone through? Any of you just go to a strange place and drink water from a tap? Like, you don't know, just go somewhere and turn on the tap, and then you're a brave person, so I give it to you that, right? So when you drink a bottle of water, you actually see what it has gone through, right? You're looking at the processes it has gone through. So it's a very similar thing. I'm able to trust this bottle of water because I know what processes it has gone through. It's a very similar thing to data, right? When I give you just an Excel file, hey, do some decision making with that, would you trust me? No. You shouldn't trust me, right? So you should ask these questions: how this data has come from the source? What are the processes that this data has gone through? Show me that and let me see if I can trust this data. And that should be a stance, to be super, super paranoid about, give me the lineage of this data, let it show what the processes it has gone through, and then I trust this data. And this is called data lineage, which is a very important aspect of making a data trustworthy, right? The second one is making sure this data is of high quality, right? Has this been gone through some structural checks? Has this semantic checks? If I give you an Excel file with, I want demographic data and all the addresses are empty, that's not a file you need, right? So it has to gone through the structural checks, semantic checks, and domain-specific data quality checks to say, this data is trustworthy in nature, right? The fourth one is self-describing, in the sense that you shouldn't be looking for people to speak to understand the data. Like once you have discovered the data, you shouldn't be like, hey, I need to speak to this person from the other department to understand this. And that's not how it should be. It should be self-describing. You should have enough information traveling along with the data set in the catalog that says, this is what this data set is there for, what are the fields, what is the business glossary, and then use that as it is from the data catalog, right? The fifth one is interoperability, which is if I want to link data sets from various teams, it should mean the same thing. Like if I want to actually link over customer ID shouldn't mean one thing in one department, another is another department, then you can't link. So there should be a standard way of what do the data elements mean within an enterprise to make it interoperable so that I can link and create insights, right? The last one is secure, is making sure that you have the right perimeter security, you have authentication, authorization, anonymization, all built in to make sure this data is secure, right? So I'm just going to take a quick pause here. If you have any question, maybe just take one at this point before I go along. Any questions so far? There's one in the back, yeah.
Thanks. So as somebody who builds microservices as a developer, you say we should try to expose data as a product. However, when I build my microservice, often I treat data as internal state while I try to keep my API stable for everyone else. So I guess what are some good practices to decouple the data as internal state from data as a product?
That's an awesome question. So some of the things that you need to consider is to see how these 6 characteristics can be taken care of. In the sense that, and we'll talk about how this can be enabled easily. So it's not that every domain needs to do this from scratch, but how can you register this data set with the catalog? How can you run the data quality checks before you expose it via an API? And how can you make sure the metadata is also served with the API? And making sure you have the right role-based access control while giving out. You're doing authentication, authorization, and maybe run some privacy-enhancing checks, and we'll talk about that soon. Before you send out are some of the good practices to say that this data can be exposed as a product. Hope it clarifies. Thanks for the question. Cool. So moving on. So what comprises this data as a product is code, data, and infra. So I'm giving, say I have an Excel file, I'm going to transform this and put it into a blob. The code we write to actually write this transformation, the infrastructure where this is hosted, and the data and metadata come together to what we call as a data product, right? So just extrapolating to our, the example that we saw earlier is artist as a domain has a payment service and onboarding service giving out operational APIs. I'm also giving out a data product via, say, SFTP. It could be any kind of a output port, which is SFTP, REST API, or I'm giving off in a blob storage, and artist history data is available as a product, right? Similarly, we were saying podcast listeners, demographic, and that's given out as a data product as well, right? So we conclude the second pillar. So what we saw earlier was don't look at data as a swamp. Look at it as decentralized across domains. Have the right ownership. And there are data product owners in each of these domains who are always thinking about what use cases I can solve with this data set and giving this out as a data product, right? Now, if you have a question in mind, hey, should every domain be doing this from scratch? If you have this question, then I probably have done something good in these last 2 slides, right? That's where the Selfserve data platform comes into play. So I think many of you are using Kubernetes, right? How many of you are using Kubernetes here? Pretty much a lot of you, right? Why are you using Kubernetes? Why can't you do things from scratch? Any takers? Maybe I'll open it to the front row. Minimizing overheads. Yep. Thanks for that. So Kubernetes, what it does is whenever you're doing container orchestration, it's going to take care of most of the cross-function concerns for you, so you don't need to really worry about scaling, deployability, so on. That's where the Selfserve data platform comes into play. That every domain, so you have tens and 20 teams within an enterprise. Should all of them be setting up things from scratch, setting up the data products from scratch? No. And that's where the Selfserve platform tries to abstract them out so that it can take care of the cross-cutting concerns for a typical data democratization. And the domains can do just enough for surrounding their business logic. Thereby, it's minimizing the overhead, like what Ankit mentioned. And the lead time to actually build data products comes down because the domains need not start things from scratch, right? So what are some of the capabilities of a self-serve data platform? Many of you, if you're in data platform teams, you're already doing it, right? What we are saying is there are 3 buckets of capabilities. One is data infrastructure, which is any kind of an analytical need would mean that I need to set up the network security controls. I need to set up data storage. It should be polyglot in nature. I need to set up the role-based access control. So all these things are capabilities that are cross-cutting across pretty much all the domains and data products. And that is a category of capabilities that we'll get from a self-serve data platform, which is an infrastructure plane. The second one is I have used the APIs to set this up, to create an orchestration layer, to create the data storage. How can I create data products easily? So to the question you had, you don't need to start things from scratch. The APIs that the self-serve data platform provides will actually combine and give you an ability to create a data product with ease, which means setting the schema of the data set, or setting up who owns this data set, the ingestion configuration of the data set. All these things are packaged as an API, which we can use to say, I can just create a data product on the fly, but what I will do is I'll introduce business logic as a domain data developer, right? So the capabilities to create a data product is served out from the second bucket of capabilities of a self-serve data platform. The third one is, I have created a data product. Now, I need an ability to maybe discover data sets across the enterprise. I need an ability to actually create a taxonomy of, this is how the data elements are related to each other. Or if I want to actually have some governance process set across the board, are all cross-cutting capabilities, which will fall under the data mesh supervision plane. So these planes are nothing but just logical segregation of capabilities, but what we are saying is there will be a self-serve data platform which is centralized, which is actually going to have these cross-cutting concerns, and that can help the domain teams to build data products with ease and in a standardized manner, right? So this is one of the most important aspects of data mesh. And if you're wondering that, hey, we are already in a centralized data setup, how can I move to data mesh? It's not a big delta. You're going to probably need to make this data platform self-serve and try to decentralize across domains to use the capabilities from the platform, right? So this is the third aspect of data mesh, which is the self-serve data platform, right? So let's come to the mouthful of words here. Federated computational governance, right? What is data governance? Data governance, simply put, is I'm able to enable ease of use of data, but I need to make sure that this data is accurate, trustworthy, and secure. And all the processes and policies that are needed to do this comes under the umbrella of data governance, simply put. Now, what is federated, right? In some countries, you have a central government and a state government. And you have a central government which is taking care of certain policies. State government is taking care of certain policies. And that is federation, right? So when we say federated computational governance, what we are essentially saying is, in your enterprise, data governance shouldn't just be at the center. It shouldn't be just a centralized function. But we are making sure that it's federated between certain things should be done at the enterprise level. Certain things should be done from a domain-specific perspective. Right? And we'll talk about some examples in this, like which ones are at the enterprise level and which ones are at the domain level. Right? The second one is computational. When we say computational, in simplistic terms, we automate wherever possible the policies of governance. In some of the enterprises, we'll see that governance is when every week there is a set of people who meet up, decide a few things, and it doesn't get to the teams at all, right? And computational, what it does is, can we actually bake in these policies, like data quality, lineage, security, into the self-serve platform, so that most of these are automated in nature? And that is computational, right? So that's what federated computational governance means. And some examples around what are some of the criteria that can fall under enterprise governance. So things like, I want to have a standardized way of creating a data product or modeling a data product is an enterprise-wide concern. Or if I want to say that each of these metadata elements mean this thing, for example, customer ID, customer name, you are doing customer 360 in your enterprise, you need to agree on what these things, what does a customer profile mean across the enterprise, right? And it should mean the same thing, right? The third is, how do I draw domain boundaries? This is a question that's often asked. How do you draw domain boundaries? And it's a case-by-case thing. It should align with your business lines. You should make sure it's not too small, not too big. So those concerns are actually taken care of at the enterprise level, right? So things that you look at the domain level are where you're looking at the schema of the data set. How can I give out the metadata elements as an API? And if I want to actually grow the number of users who are using these products, what could be the incentive around that, right? Like data is the new oil, and if you're just having you're just having cans of oil, but you're not giving out, you're not becoming rich anytime soon, right? So there should be an incentive that how do I make the best value of this data? Who can I actually reach out to as users to give this data is a domain level incentive. And wherever possible, I'm going to automate this on the platform so that it's a computational governance. I'm going to take in the lineage, bake it into the platform, take in the security policies, bake it into the platform, and make sure that enterprise-wide governances are all regulated from the platform. So when I create a product, I'm actually taking in these governance policies automatically, right? So this is the last pillar of data mesh, which is the federated computational governance, right? So before I move on and summarize, just to call out, data mesh also gives an ability to handle data privacy really well. And why is that the case? Because we are already categorizing domains. And when we classify, some domains might be more sensitive than others. For instance, if I'm in a health analytics company, I would probably have an activity domain which is fairly not so restricted, but I have medical data, which I have diagnosis of patients. That's a very sensitive domain. And the way you will handle data within that domain would actually vary, right? So classifying domains based on sensitivity is very important. And when you give domain data owners the independence to do stuff, they understand privacy really well because they understand their data model well, which means they understand the trade-off between privacy and utility well. So for instance, I have a file of all PII data, NRIC, name, address. Now I'm saying I'm going to be super conservative. I'm going to remove all these things and give it to you for analytics. Can we even do analytics without some of these fields? No, right? And it's important for the domain data owners to actually do this privacy versus utility trade-off. And they know the best because they are the ones generating that data, right? The third is each domain is a trust boundary. I'm borrowing this word from one of my colleagues here. The trust boundary is nothing but your domain data owners are empowered in such a way that they want to do privacy-first design. You are giving them the accountability. When you give people accountability, they do amazing things. So when you give the domains the accountability to build privacy-first design, what we are also telling them is, I'm going to build privacy-first design. You come into this, you can trust anything within this domain. It becomes a trust boundary naturally. And we are making sure that everyone has testing and auditing in place so that this is also monitored at the enterprise level. Right. What federated governance, which we saw, is empowers the domains. The Selfserve platform will implement the governance, which is enterprise-wide governance policies, making sure that we are taking care of privacy also very closely. So things like privacy-preserving technologies, differential privacy, homomorphic encryption, you can actually write the Selfserve platform in a way, when you want to create a data product, there is differential privacy checks that are happening before your data product gets used, right? So by right, you're already baking in the privacy-preserving techniques into the platform, and having the right controls in place like k-anonymity checks and differential privacy will make sure not every domain needs to do that. It's all governed at the central level, some of these concerns. And with all the combination of this, what we are saying is data mesh by design, actually is much more suited for building privacy-first applications. Right? So I'm going to summarize all before we open it up for questions. So we saw 4 things, and all these 4 pillars need to come together to say, this is a data mesh approach. And why do we do this? We do this so that we can democratize data at scale. We make sure that we can support analytical use cases at scale. So the first one we saw was domain-oriented decentralization. You orient your data around domains. You have the right responsibility and accountability for these data sets. The second is treat data as a product. Don't think of data as something I'll throw from one fence to another, but treat that as, it solves a purpose, and it has to be discoverable, accessible, trustworthy, interoperable, and secure to say that this is a data product, right? The third is self-serve data infrastructure as a platform. Not every domain should be in a business of writing things from scratch. The self-serve data platform gives you the capabilities in a way that each of the domains can create data products with ease. And the last one is federated computation governance, which is to make sure the domains also have responsibility from a governance perspective, and also the enterprise having certain policies. And we are going to bake these into the platform as and when needed, right? So with this, I'm just going to leave you with a quote and open up for questions. It's from the author herself. This is a decentralized architecture where data is owned by domains and the teams that know this data really well. And we have the right roles which are allocated from our ownership perspective, where data is treated as a product, and you have a self-serve infrastructure layer that helps create these products easily. All right. So I'm gone on a rant, and I'll probably open up for questions now. Yeah. Maybe. Can grab the mic, please?
So thank you. This is the second time I'm learning about it. One I learned in the YouTube.
Sure.
And from that time I'm struggling with following. So there was a time when we started individual application, then data lake came,
yep.
And now this is another paradigm shift, right?
Yeah.
And universities and everywhere data lake is still popular. And I mean, you talk to anyone, you get a project like data lake kind of project, right?
Yep.
Given that I have gone through one of the data lake application and I saw the challenges is basically remains in the data, not the way we design it, right? Mm. So, now let me phrase my question. Do we have a framework which tells that, hey, such kind of applications are, or such kind of products are suitable for data lake, and such kind of products are suitable for data mesh?
Mm.
So that it becomes quite easy to, look at the pros and cons and justify it.
Right.
Thank you.
Sure. Thanks for this question. Let me actually go a little bit further. When we started about when to consider data mesh, right? And I'll probably use that for. So you have a very valid question. And 5 years back, I was doing data lake and data platform. I was actually a critic of data mesh, frankly, because I didn't quite believe in something I've been doing for several years, and then you are giving me a data mesh one. So the way I would see this is that every trend takes some time to evolve and to catch up. So if you see a decade back, Hadoop was just catching up. So we were still having things where we were writing to relational DBs. In 2015, Hadoop became a big deal. Everyone started to do data lake because we felt that compute has to stay close to data, and that's a very, very fair thing. So with data mesh, what we are saying is it's not going to replace data lake. What it is I would still have my data, like from a technical perspective, you still have a Hadoop on-prem, or if you're having a AWS setup with S3, you will still have those from a technical perspective. But what we are saying is, if you are in an enterprise that has to scale with the new analytical use cases, that's where it fails with the centralized setup. Just like how microservices came from a monolith, it doesn't scale. And when you want to scale is when we look at something like a data mesh. And if you see the things where we say we want to consider data mesh is all when it goes beyond a scale. So if you're okay with just a couple of teams sharing data with each other, I have very little data, then You don't even need to go to data mesh. You can set up things and run with it. But say your scale is becoming that I am looking at 20 and 30, an increase of producers and consumers every month with new use cases coming in, then this centralized setup will not scale. And that's where we are saying that it's good that you decentralize. You still can use the same technologies that we use for the data lake, which the Selfserve data platform can set up. But the way you will actually structure the teams and the people and processes will be in a decentralized fashion. So to your question, when do we consider that? When you're looking seriously to scale beyond a point, then that's when you look at something like a data mesh. Hope it answered your question. Maybe one more question before, and I'm happy to answer questions. I'll be around to, please go ahead.
Hi, thanks for the talk. It was really good.
Thank you.
My question is about ROI. So the sound of a decentralized self-service data platform is clearly appealing, but I think many organizations would struggle to prioritize the investment in time and political capital to build those capabilities around many different branches of the organization. How would you succeed in driving an effort like that?
Yeah, that's a great question. I think this struggle is not new to the tech world, right? Whenever you have a new concept, it's hard to get this through the first time. Like 10 years back, people were just building monoliths, right? But how did we push to microservices? The way we are doing it today, when we speak to the clients, it's the same question that gets asked, which is, what is the ROI? And we are looking at case studies where we have seen this happen, that you just take one domain, you set up this framework, and we were able to create 50 data products in 2 months. Now, would I have been able to do that in a centralized setup? No. So the way it would start is in an incremental fashion, where you start with a very low-hanging fruit, choose a use case that you would want to pilot with, start with a domain with its own responsibilities, build the data products for this use case. Then you see that as a cascading effect. You actually see this team is able to spin up things much more faster, and then you take it through and replicate it within an enterprise. It could not be done big bang. It can only be done in an incremental fashion, because this is also an organizational change, which is coming in for a more strategic purpose and not something I can just set it up and run with it. It's a thing that we need to understand, that let me pilot it, and then I'll replicate it across the enterprise to look at the incremental ROI. So it has to start small and grow. And that's how the companies are doing it. And we have seen this happening in places where you are able to spin up 50 data products in a couple of months, which is not the case. Like, it would have taken 5 to 6 months to actually set this up and run with it in a centralized fashion. Yeah, hope it clarified. Okay, so Edward has been looking at me for some time, so thank you all. This has been a pleasure to talk here. Yeah.
Thank you so much, Sowmya.